Alright, so today we're adding fractions in our algebra class, and we're also talking about the least common multiple. We're going to go through the process of adding fractions. We'll do it a couple different ways. We'll do it one way, we'll do it an elegant way, and then I'll stay tuned and I'll show you a shortcut on how to add fractions. A super fast shortcut. You will love it. So first, let's start adding some fractions. Let's break them up into two cases. The case where they have the same denominator, and then we'll do the case where they have different denominator later. So let's start off with an easy case. Suppose they have the same denominator. That would mean something like this. One way to add this would be to say, you know what, you have no business adding fractions if you don't know what a fraction is, or if you don't have a strong definition of a fraction. Thankfully, we have a very professional definition of a fraction. We said that 3/5 is defined to be 3 times the multiplicative inverse of 5, or 3 5-killers. Likewise, 4/5 means 4 killers of 5. That's by the definition of a fraction, which we studied a while back. Now you can look at this and say, whoa, I have two terms here. It looks like someone went ahead and distributed a 1/5 using the distributive law. You say, maybe I can undistribute it. That would leave me with something like this, 3 plus 4. That's definitely legal by the distributive law, and there's always two questions. Is it legal and is it helpful? First, it's legal because if you were to distribute it, as I said, using the distributive law, you'd get back there. That's distributive law 101. For sure it's legal. Why is it helpful? Well, think one or two moves ahead. If you just think one move ahead, you could go on and add the 3 plus 4 using the addition table, and then you could put it back up here using, again, the definition of fraction. And so you're going to be done in about 2 seconds. Or you can just go ahead and use the definition of fractions. This quantity right here can go up here and replace the 1. By definition, this multiplicative inverse of 5, that means the same thing as 3 plus 4 all over 5. That's the same definition we used at the beginning. To bring them down, well, you can bring them back up. Clever, huh? First use the distributive law, and then you can go on and use the addition table if you wanted to. This would be 7 over 5 by the addition table. And that right there is a very professional way to add fractions step by step. A professional way to see why when you have the same denominator, you don't do anything. All you do is leave the denominator the same and add the tops, the numerators. That was so fun. Let's try it again. Suppose you have 2 over negative 7 plus 3 over negative 7. Again, use the definition. This is 2 multiplicative inverses of negative 7. This by definition means 3, 1 over negative 7s. That's the definition of a fraction. And you can say, whoa, it looks like someone distributed a 1 over 7 on both of these. Maybe we could undistribute it, and that would leave 2 plus 3. And that, of course, is a distributive law. And then you could put it back up there. That's 2 plus 3 all over negative 7 using the definition of A over B. And that's it. Or you could actually take another step here and use the addition table. 5 over negative 7 by the addition table. That right there is professional step-by-step way of adding fractions that have the same denominator. Now these steps are so repeatable that we package them into one theorem called the ATT theorem. Add the tops theorem. Add the tops theorem, which means that if I have A over C plus B over C, I get the same thing as A plus B all over C. By the way, reading it that way, add the tops means if you have the same denominator, all you do is add the tops. If you read it that way, it means that if you have an addition on the numerator, you can split it up into two little sums, two little fractions. You should be good at reading it both ways, that way and that way. And of course, there's an exception to this. Zeros on the bottom, we have to handle different. You can't have zeros on the bottom unless, of course, you're Chuck Norris. Or if you pay extra money, maybe I can show you how to have zeros on the bottom. Alright, that's the package right here. Add the tops theorem. It works perfect when you have the same denominator and same non-zero denominator on the bottom. So, and there might be other exceptions, but maybe we shouldn't talk about them yet. How about this? Alright, so that means that if this is given, we could go on and use the ATT. That would mean 1 plus 6 all over 8 by the ATT. That has the package of all those steps built into it. And of course, that's just 7 over 8 by the addition table. Yippee-ki-yay. Okay? That was so fun. Let's try it one more time. The idea is so powerful. It works not just for regular numbers. It'll work on these fractions and all the fractions that you will ever learn in any math class through your bachelor's degree, maybe. It'll work on most of them. Alright, so here we go. We have x plus 1 on the bottom. So you have the matching denominators. So therefore I can say this is x plus 1 all over x plus 1 by adding the tops. ATT theorem. If this was the given, I can go on to that step. And then I can say, well, this is just 1 by the just 1 theorem. There you go. Yippee-ki-yay. We added. That's how we handle fractions that have the same denominator. The trouble is that sometimes they don't. Sometimes you get fractions like this. Those have different denominators. And so you can't, if you try to play the same game here, 1 over 8, you could bring down the 1 plus the 2, you could bring down the 2. You can't say, whoa, it looks like someone distributed a 1/8 because this is not 1/8. Likewise, you can't say, whoa, looks like someone distributed a 1/5 because that's not a 1/5. And so that's where the party stops right there and say, well, we can't really go on any further until we have other brilliant ideas. So let's put this on pause here. Give it a try if you want. We'll come back and learn some new ideas to handle fractions that have different denominators.